Okay, so for the first video of Chapter 1, Unit 1, we're going to be looking at measures of central tendency. Now, you've probably seen these before, even if maybe you haven't heard it actually called that. So we have three different types of measures of central tendency. We've got the mean. This is the usual one that you'll see. If someone wants a middle value, they're going to find the average value. That's going to be the mean. We find that by adding up all of the data values in the set and then dividing by however many data values we have. So it's a simple average. The second one is the median, and this is just simply put the middle score. Ignoring anything on the outsides, whatever is the middle of our data set, that is the median. And then our third type is the mode, and that is the most frequently occurring items. So if we have a list of data and everything shows up one time except for there's this one object that shows up 3 times, that would be the mode because it showed up the most. Even if it's not in the middle, if it's not the mean or it's not the median, that's a different measure of centrality. Okay, let's look at a couple problems using these. So Alina knows that her morning cup of coffee is a discretionary expense. She doesn't need it, but she wants it. She pays $2.75 for a 9-ounce cup and was wondering if that is a typical price. So on Monday, she asks 6 of her coworkers what they pay for a 9-ounce cup of coffee. Their costs were $2.85, $2.15, $1.95, $3, $2.05, and $2.40. So how can Alina compare her expense with those of her coworkers? Well, to do that, she's going to want to find the mean of the 6 prices. She's going to want to find the simple average. So to do that, we just add up all the values and then divide by 6. So if you add up those 6 prices, you get $14.40, and then divide by 6, you get $2.40. Now, a big part of this class is not just finding the numbers, but realizing what they mean. So what do you think this means about Alina's cup of coffee? Well, it says that she's paying $2.75, so she's paying 35 cents more than the average of her coworkers. That means that if she's really worried about how much she's spending on coffee, she may want to find a less expensive coffee shop. A thing that comes up a lot when we're talking about averages is sigma notation. So this is the Greek letter sigma here. It's capital sigma. And it's just a shorthand way to say that we want to add up a bunch of numbers. Instead of writing all of those numbers out, we can use sigma notation and say add up this set. So we can pretty easily use that in averages. So we've got a lot of symbols here. So this X with a line over it, this is actually called X bar. And that means the average, the simple average, the mean. And then over here, we've got our sigma, and this is the lower and upper limit here. So this is the index. It's saying that we're starting at value 1, and the upper limit is n. That would usually be an actual number. So if we have 7 values, then that n would be 7. And because we are finding the average, we want to divide by however many values we have. So we would divide 1 by 7 in that case. And then this here is called x sub I. That's how you would say that. And what this is saying in sigma notation is that I'm going to take the first value, and then I'm going to increase this by 1. So I'm going to add it to the second value, and I'm going to increase it by 1, and then I'm going to add it to the third value until I get up to n values. So it's just a shorthand way so we don't have to write everything out quite as often. Let's do the same problem, only let's write it in sigma notation. So we can write our prices as a table. So our x sub 1 is $2.85. Our x sub 2 is $2.15, all the way down there. And then we can write that in sigma notation. So our x bar, our mean, is 1 over 6 adding up our index from 1 to 6 of x sub I. And then to solve that, we just do it the same way. We add up all the numbers, and then we divide by 6, and we get $2.40. So it's the exact same answer as before. It's the exact same way to solve it, but the original problem, if we were to just write it like this, is in much more compact notation. Let's look at another problem. So Anthony wants to make the discretionary purchase of a basic laptop computer. So he's got a particular make and model in mind, and he checks a shopping comparison website to see some prices. So he finds these prices: $850, $798, $2,400, $790, $836, $700, and $780. So he wants to figure out the average of these prices to know about what he's looking for, and he calculates that average, that mean, to be $1,022. Is this a good representation of the center? No, it's not. This $2,400 value is what's known as an outlier. It skews our data set. So our average is going to be heavily affected by that 2,400. So that means that the mean and the median are going to be pretty far apart. So when that happens, the median is often a better representation of the middle, because medians are resistant to extreme numbers, and we'll see what that means in just a second. To find the median, all you have to do is put the data set in order and then just look for the middle value. So I've gone ahead and I've put these 7 numbers in order. Since there are 7, our middle value is number 4 here, so the median is just $798. And this seems like a much better middle price than $1,022. And now notice when I said that this is resistant to extreme numbers, if I change that 2,400 here to 24,000, it's going to change that mean by a lot. It's going to raise that a ton, but the median would still be the same. So as long as we've only got 1 or 2 outliers, the median value is, there's a good chance that that's going to be a better way to look at the middle. Okay, and then last thing here, let's say that Anthony only found prices from 6 vendors. So how can we find the median of a data set with an even number of objects? When we had an odd number, it was pretty easy. We just looked at the middle one. But now we don't really have a middle, we have 2 middles. And the way that we do this is we just average those 2 middle values. So we've got 6 numbers here, and the 2 in the middle are this 798 and this 836. So we're just going to add those up and divide by 2. So with our 6 data values here, our median is 817. And note that even though we had to do that average there, it's still very resistant to outliers. So again, we could change this 2,400 to a 24,000, and it wouldn't actually change the median at all. It would still be $817. Okay, that's all we've got for central tendency. We'll talk more about mode in class, and I'll see you tomorrow.